So we now continue further on the Gauss law and divergence theorem. The Gauss law, what you have studied, takes into consideration the closed surface, and it considers a finite volume closed by that surface. And for say last time we started with the point charge at the center of a cube, so that the net outgoing flux from a surface is equal to the direction is different. So we have the concept of area vector and the electric field vector. When the enclosed surface is there, area vector is perpendicular to the surface pointing outwards. So the net electric flux passing through any small given area is the dot product of which two vectors? Net electric flux passing through a small area is dot product of d and ds, where d is the electric flux and ds is the area vector. So as the example which you have considered is simple, that it is symmetric. Because of symmetry, the Gauss law states that the total electric flux passing through a closed surface is equal to charge enclosed. So what we have done, we have 6 faces of the cube, q charge at the center. Since all 6 faces are symmetric to the charge, the net outgoing flux from each surface must be equal to 1/6 of the total outgoing flux. And as Gauss law states, that is equal to charge. So from one side of the cube, the total electric flux passing through must be q by 6. Total electric flux passing through must be q by 6. So what should be there? D dot ds means it is, if we consider this as one side of the cube, at each point actually point we consider to be the limiting case of this small square whose sides are dx and dy. So a small square of area dx dy is this vector, is this d capital S, whose direction is this. So ds is a vector in this direction. But however, the electric field or electric flux d will be having some direction like this, because at the center it is q is there. From the center, if you consider front face, at one particular point it will be like this. So that is the direction. Therefore d at every point will be different. Are you getting me? The electric flux density at every point will be different on the front surface, and its net electric flux going out is dot product of d dot ds. So d dot ds is different at every point. What is ds? ds is dx dy. So d dot ds, what is d? Now d dot ds you do. D is electric flux density. So if I add, for simplicity we have taken the charge at origin, and the cube we have taken of this length to each side of 2 meters. So that if charge at the origin, the front surface at z equal to 2, at z equal to 2, the limits of it are 1 means x will be from -1 to 1, y will be from minus 1 to 1. So at a point xy, what is d? D at a point xy will be equal to, no, not ds dy, ds. What is d? Electric flux density d at a point on the front surface of the cube which is located at z equal to 1 will be q upon 4 pi epsilon is not the in E epsilon is the denominator. When we consider d, epsilon equal to d into 1 upon r square. What is r? R is z equal to 1, x and y as it is. So under root 1 square plus x square plus y square. So square would be 1 plus x square plus y square. Right? Is it okay? What is the direction? This is the electric flux density magnitude. What will be the direction? Not outward. Means outward is not a complete answer. Exact direction. What would be the unit vector representing that direction? What would be unit vector representing that direction? Kitil? लक्षात लगा? Front surface, origin. So we are at a point. This is origin, not origin. This is projection of origin on this surface, and this is the point xy. So something in this direction. How will you find the direction? What would be unit vector representing the direction? Is it clear? Electric flux density D is a vector quantity. If origin is here and a charge plus q is there, then at some point, at this point which is at x comma y comma 1, बरोबर का? It is a simple question. Calculate. आता D म्हणल्यानंतर वेगळं वाटत असेल तर E म्हणूया आपण. Right? Calculate electric field intensity E at a point x comma y comma 1 because of the plus q charge at origin. What it would be if it is E, epsilon will come here. Otherwise, so 1 upon q upon 4 pi, 1 plus x square plus y square. This is magnitude, and direction will be by a vector r cap. R cap is unit vector in that direction. R cap is unit vector in the direction. So what would be R cap? R cap will be something into ax plus something into ay plus something into az. Right? So how will you calculate? This is not rocket science, but this requires a very sincere approach. What is the answer? उत्तर आलं का? यात नाही असं काही आहे का? Calculate electric field intensity. Coulomb's law चा प्रश्न आहे. पण पुढचं नाही काय येतं, गॉस बीस काय नाही येतात त्याच्यामध्ये. ते पुढे येईल. Calculate electric field intensity E at a point x, y, 1 because of a a point charge of plus q at origin. Origin आणि x, y, 1 याला जोडणाऱ्या युनिट वेक्टरची व्हॅल्यू काढायची आहे. कशी येईल ती? What is unit vector? Represent unit vector r cap. किती? Represent unit vector r cap from origin to x, y, 1. किती येतो? किती? काय अंडर रूट आणि युनिट वेक्टर युनिट आणि प्रश्न काय आहे? प्रश्न काय आहे? युनिट वेक्टर काढायचं आहे. त्याचं उत्तर काय असतं? समथिंग इंटू ax प्लस समथिंग इंटू ay प्लस समथिंग इंटू az, where ax is unit vector in x direction or I म्हणतो आपण. This is unit vector in y direction, this is unit vector in z direction. त्याला आपण ax म्हणतो. तुम्ही मल्टिपल ठिकाणचं बघत असाल तर काही ठिकाणी I असेल, काही ठिकाणी x कॅप असेल. What is this? What is this? What is this? हे किती? x upon under root x square plus 1 plus x square y square. हे किती? आणि हे किती? 1. Right? So this you must know. Fortunately, this may not be required. Why? आपण माहितीची गरज नाही. This magnitude is known. Right? What we are interested in? We are now proving Gauss law. So we want total, what we want? D dot ds. D dot ds. On the front space, ds is in which direction? ds is in which direction? On the front face, dot d bar dot ds bar. ds bar is in which direction? Which direction? What that is? Z. In the positive z direction, right? Therefore, what d dot ds will be? D dot ds will be the direct product of what will be ds is already in z direction. So z component of ds will be dx dy directly. So d dot ds will be, this will be dx dy. And do you agree? D dot this will be a scalar. Right? D dot this will be scalar. Dx dy is the value of this ds. Its direction is z. So what is, to be very precise, what is ds? ds vector is equal to dx dy into az. Right? What is d vector? D vector will be something into ax plus something into ay plus something into az. So dx, dy and dz. Right? So a dot product of ds and d, this ds is not having ax, ay, all both are 0. So what is dot product? Dot product is x component of first into x component of second, y of first, y of second, z of first, z of second. So these two values are immaterial for me. So what and this is dz. So dz into dx dy will be d dot ds. So what I want, I am not interested in this direction, but what would be dz? dz would be the projection of this on z axis. ते सोपं आहे. ते किती येईल? This into Now this is a scalar. dz is a scalar. dz is z component value. So it is in the direction of z. So dz az it comes. So dz will be this upon this into what? Into z component. 1 upon under root 1 plus x square plus y square. So d dot ds will be q upon, or q upon 4 pi will be outside because that is a constant, into 1 upon, or we can write dx dy upon 1 plus x square plus y square raised to 3 by 2. Is it right? Is it okay? And then what would be total net outgoing flux to the surface? This is the outgoing flux through a small area dx dy. For the whole surface, it would be in double integration from -1 to 1 of q upon 4 pi, that is d front. D front means what? Net outgoing flux through front surface. Right? And what this integration should work now? Answer should be q by 6. Answer has to be q by 6. So this integration, the sum means q upon 4 pi into something should be q by 6. The something should be, it goes there, 2 pi by 3. This answer comes as 2 pi by 3. Now, if you know the answer, from that you try to solve it by substitution something. It's double integration. So in double integration, you either dx dy. So these are the limits for dx. For that y is constant. And then these are the limits for. So here to the solve.